All right, guys, welcome to the third class of ACT. I know we have some students online already. Um, just want to double check that you guys are doing the homework. I know we have one or two students who joined late. Take your time, get used to it, but make sure to watch the videos. But students who have been here from the day one must be doing the homework. That's not a negotiable item because if you want to do well, you really have to do the homework. Second, if you guys want to write down this, so April 10th, April 10th, 1 to 4 p.m. is the ACT review, as we discussed before. And I know that many of them have signed up. Some have already paid. Some have already paid, some have not. So we are getting almost to full actually. So you want to make sure you contact your parents if they want to sign up. This is the most important program. You don't want to miss this. Okay, this is for the students taking the April test or the June test. So there's a fees of $65. I think you both are signed up actually. You guys are okay. So Bella, you wanna talk to mom about this, okay?
Yep.
So if you're online, I hope you guys, again, many of you have already registered. Make sure to check with your parents on this one. Very, very important on to get this taken care of. Before we get going with the class, is there any comments, complaints from the first 2 weeks of the class? And again, I always expect you to be honest. I'm going to be honest with you guys. So even if you're online, you guys need to unmute and speak up, and if there's anything we can do better.
Just one quick question for the ACT review.
Uh-huh.
So, is that going to be online and face-to-face?
Yes.
Okay. And then do we pay you through...
Yeah, many people are paying by Venmo or PayPal. Some people came to my home, dropped off the cash, whatever.
Gotcha.
Yeah, whatever is comfortable. But main thing is for you guys to make sure to register because I don't want other people to take your spot once it's full. Okay, so we're gonna reserve the spots for you guys first. Okay.
Is that here then?
What are we expected to bring?
Just a calculator. And your wonderful smiles. Yep, that's all.
Is that here then?
Yeah, same here. If you're face to face, this is gonna be here. If it's online, this will get same setup basically. But we expect a lot more students to be face to face. That's based on what I've heard. And it's pretty. I know it's 1 to 4, but it's actually we open the doors at 12:30 itself. Actually, we start at 12:45 because we really do not waste even single minute, and we're almost kind of getting to a point of almost we're ready with our preparation with all of Lauren and Maddie and stuff like that. So good. Next, we are going to continue with our trig studies. So you open page 4 and 5 of the math packet, your notebooks, your calculators. Let's get swinging, okay? Again, I like that you guys asked a lot of questions. There was a lot of discussion. Keep up the momentum, okay? So what we're going to do is, before we get into deep problems, I'm going to do just a warm-up problem, just to get the juices flowing here, okay? Try this one, question number 1. Find x minus y. Stay focused on the fundamentals. Always remember how much time you're taking per question. Again, the routine continues. If you're done with the answer, you unmute or just say your name so I know who has done it and how many have done it. Always make sure the calculator is in the degrees mode, not in the radian mode. Anyone?
I think I got it.
Good one.
Matt Brown.
2. All right, Matt, what do you got?
Well, I just found the cosine of x to be 18 over 249, and then I did the sine of y, and I just subtracted those from each other, and I got 0.99. I have no clue if that's right or not when I rounded it all.
But you're supposed to be x minus y, not cosine x minus sine y. The answer will be in degrees. So the difference is in degrees. Bella, what do you got?
I did cosine 18, 29 over 29.4 to find x, and then I got that, added it to 90, and then that total subtracted 180 to get my other angle, and then subtracted the 2, and I got like 14.5 rounded.
Okay, let's get started here. Open page 5 of the math packet, and I want everybody to put your pens down. Listen up. You should be looking at maybe 30 to 45 seconds for this problem. If you take more than that, that means you do not know the fundamentals. So, when you're looking at an angle x or y here, this is what we call a trigonometric inverse. Okay? So let's focus on x here. Cosine x is equal to adjacent or hypotenuse 18 divided by 29.4. The question is not the trigonometric function, the question is what is the angle x? So x is equal to cosine inverse of 18 divided by 29.4. Get your calculators? Let's get started here. This is called a trigonometric inverse, and an inverse is used to always find the angle using the trigonometric function. So cosine inverse 18 divided by 29.4, I'm getting 52.25 degrees. Again, let's not worry about decimals and stuff like that. Now, y is 90 minus of that. 90 minus 52.25 degrees. I'm getting 37.75 degrees. So x minus y is equal to 52.25 minus 37.75 degrees. 14.5 degrees. Bella, is that what you got?
Yeah.
Okay.
I just added, like, I just didn't do 90 minus
Yeah,
52.5.
Yes.
I just got this calc. Can you show me how to put it in degrees real quick?
Go to mode at the top,
Yeah.
go to third one, and then highlight the degrees from radians.
Oh, okay. Yep. Thank you.
Matt, does this make sense?
Yeah, I got you. I just forgot to do the inverse.
And remember, from today onwards, whenever you see the inverse, doesn't matter whether in pre-calc, calc, doesn't matter. You see the trigonometric inverse, you're always getting an angle as an answer. On page 5, there is a statement I've written, and I want you to highlight that you have a math packet, you have a pencil packet we have given, and there is a highlighter. Highlight that. An inverse will be used to find an angle using trigonometric function. Always. So, anytime you see this, it always leads to an angle. Are you guys clear on the basics? So what does a trigonometric function does? It gives a ratio of two sides. That's it. Boom. This is function. What the inverse does? It uses the function to find an angle. Degrees is the preferred unit. This is all cosmetics. This is the easy stuff. This is where the fun is. Next.
So on the ACT, will everything be in degrees?
99.99%.
Okay.
If it's in radians, they
It'll
usually
say
see the
like-
pi stick out
Okay.
in the answer choice. Okay, this was a question number 60 in the ACT. This is real challenge problem for you guys. All right? I'm gonna give you guys 5 minutes time to do it. But if you know the basics, you can do this in 30 seconds. So let me complete the problem, then you write it down, then you get started, okay? Do it. Find cotangent of cosine inverse of b over square root of a squared plus b squared. The entire term is a square. Think. Just don't write anything in the book. Think. Get your process in place, then solve. Some of the students who got this question were able to do it in 45 seconds. Some who rushed took a long time because they're panicking by it looks complex. It's not. And again, if you're done, unmute and tell me your name.
Damon.
there a cotangent on the calculator?
Nope.
Nope, there is not. Oh, it's just one.
Always focus on the fundamentals. Always.
Done.
Okay. All right. Damon, what's the answer?
I got b over a squared.
That's correct. In the real ACT, they wrote it as b squared over a squared, but the same thing. Good job, Damon. That's pretty good. That's really good. All right, let's focus. Again, when I'm explaining, I would like you to put your pencils down, listen, because writing is easy, right? Anybody can do that. What you write is important. What you understand is important. So I just mentioned that if you have a trigonometric inverse, it always leads to an angle. So this is an angle. And there are only 3 angles in triangle. Of course, one of them is 90. So it's not the case. So it's angle B or angle A. How is cosine defined as adjacent or hypotenuse? Which angle has an adjacent side of B? A. So this entire thing is angle A. Right? And what is cotangent? Which is tangent A is opposite or adjacent. Cotangent A is inverse, B or A squared. That's what Damon has. He has to have done this way. There's no other option for him. Because he focused on this part, that it leads to an angle. Did you see how fast he could do it if you know the basics? That's what I was trying to get to. ACT knows you have only 60 minutes, 60 questions. They know that. So they want to design such a way that if you know your basics, you can get it across. Questions? So what does the inverse gives? Angle. If you forget in college, you're going to struggle. Right now. Can I erase this? Go to page 6 of the math packet, please. We're not done with trig, okay? We're not. At the bottom of page 6, there is degrees and radians. I'm going to give you guys 2 or 3 minutes to read that stuff, and then we're going to directly get to the problems. Historically, we have been seeing one question per test from this topic. All right. Again, there's nothing for you guys to write now. Stop writing, listen up, okay? Again, if you're online, I would like you to participate by unmuting and answer questions. I just don't want you to be a spectator here, okay? I want you to be a part of the game. When I draw a circle, how many degrees does a circle represent? 360, right? We always have been used to writing the circumference is 2 pi r. Am I right? We kind of know that from even maybe from 5th grade. Circumference is 2 pi r, area is pi r squared. Today we're going to get into the basics of why it is so, okay? We know that if the radius increases, circumference increases. Am I right? What is the one thing that did not change? The angle remained the same. The 360 didn't change. So how did they represent that 360 degrees in the equation? 180 degrees is pi radians. So 360 degrees is 2 pi radians. That 2 pi is here. So a circumference is equal to the angular degrees in measurement in radians times the radius. So it's already there. You guys with me? And of course pi is 3.14, that doesn't change. So 180 degrees is pi radians. 90 degrees is half of it, pi by 2, and so forth. Sounds good? How would the question be given in the ACT? Question number 3. Convert. This was in the real ACT, by the way, this question. 2.25 pi radians, 2 degrees. Convert 2.25 pi radians, 2 degrees.
I'm done.
Do you want us to unmute when we're
Always.
done converting? Okay.
This not only helps me what's going on, this also helps you guys to participate in the class.
Absolutely right.
I just want to remind everybody that if you are in a regular group, you got to join Maddie's section. If you're in advanced, stay here, okay? Simon, I think I saw you join here. Simon, you should be in regular group, please. All right, so pi radians is how many degrees? 180. So 2.25 times 180, how much is it?
405.
405 degrees. If you know this, you can do it in 10 seconds. If you don't know, doesn't matter what you do that day, right? Unless you just guess it, right? I tell my students this. If you sit there and wonder what's going on, you're literally wasting your time. You just don't know it, move on. But do not ponder, oh my God, I studied this. How can I not know this? Emotions don't have any conversion in ACT. It's just absolute waste of time. You guys got this? Online students, did you get this?
Yes.
Yep, we got it.
Yeah.
Any questions? Any doubts? Question number 4. Convert, again, another question which was in ACT, 84 degrees to radians.
Sorry, Manoj, going back to that first question,
Uh-huh.
would we have to divide pi out to get rid of? Oh wait, no, never mind.
Pi radians
My
is,
bad.
yep. Mm-hmm. I'll be back in a second, guys. So.
Matt.
All right. Let me tell you how, you may have got the answer correct, maybe the form may be different, how ACT prefers this, okay? Let's fix it up here. All right. 84 degrees. We know the conversion, pi radians is 180 degrees, so pi radians is 180 degrees. Like a literal conversion, degrees cancels. Now, what I'm going to do is, and you can do this with me actually, okay? If you have a scientific, if you have a graphing calculator, this one, do 84 divided by 180, you get a decimal like this, okay? Then do math 1, enter. You get a fraction like this. Math 1, enter. Math is on the top left.
Oh, math, okay.
Math 1, enter. You get 7/15. This is how they're gonna write in ACT. This is how it was written. So as soon as you read the question, if you look at the answer choice, you'll know what format they have maintained the answers. Excuse me. Make sense? Ryan, did you get it? Okay. Of course, if you want the decimal form, you take 7 times 3.14 divided by 15, which is 1.47 radians, this is also fine, but 99% you will see this answer choice. Make sense? Any questions? Any doubts? Remember, if you understand the basic core principles of anything, you'll have longer periods of understanding, and you're not flustered because you know what's the basics are. You can do 10 problems of this, but if you do not know why these two are connected, you'll always struggle and how they're connected. Question number 5. Convert 1344 degrees to radians, and I want your answer in both these formats. Go.
Damon.
Mm-hmm.
Done.
I want the fraction reduced.
You'll always see the most reduced answer. So.
Okay.
Mhm. Again, all the questions you are seeing on the whiteboard are all in the real ACT. So 1344 degrees times pi radians divided by 180 degrees. Just directly give me this answer.
112.5 divided by 15.
Radians
Yeah.
Yep.
or
23.4.
4?
4, 5.
Yeah, something like that. No, that's a good thing in ACT, they don't care. So
No, it would be,
they will be around 23, that's what they say.
it would be 4.
Questions, guys? I'm gonna give you a 30-second breather. Anything you wanna ask, now is the time. Yes,
Can I ask something that's not directly related to
Sure.
math? So I saw that the SAT canceled the writing portion of the test.
yes.
And I was planning on taking the writing portion this time.
Mhm.
Do you think since college, by the time that I go to college, ACT will probably have canceled the writing? I would guess that ACT would have canceled the writing portion by then.
I doubt.
So do you think I should take it?
Yeah, you should take that. Everybody's gonna shift from SAT essays who is not taking that because it's canceled are shifting to ACT writing.
Okay.
Yep. Mhm.
So.
Once you get the 8 and higher score, you're done. You don't have to repeat it again. But yeah, I expect you to be done with the ACT writing. But yeah, don't. I have a strong feeling that ACT won't go with SAT on this one.
Okay.
I just have no understanding why SAT did what they did. College Board did what they did, but that's their choice. But I don't think so. ACT is going to follow suit.
Okay.
And I, as a college president, can tell you for sure they shouldn't be doing that. I need to know whether you can write or not in college. So. Good. Let's move on. Next topic. Question number 6. We are going to go to law of sines and law of cosines. So remember one thing, so far the focus has been a right angle triangle. Now we're going to shift from a right angle triangle to a non-right angle triangle. How do you calculate things when it's not a right angle. Okay? So if you go with the law of sines, so sine A or its opposite side is equal to sine B divided by its opposite side is equal to sine C or opposite side. This is the law of sines. It's a ratio between the angle and its opposite side, related by the sine function. Law of cosines, and I'm just going to pick one side. You can write it for every side, but I'm just going to pick for one side, b. b squared is equal to a squared plus c squared minus 2ac cosine b. So it's the opposite angle cosine is related to. So keep an eye on that one. So these are opposite. Yes.
Do these work with any triangle or only acute triangles?
Only triangles that aren't 90 degrees.
Yeah, any triangle which is not 90 degrees. It actually works for 90 degrees. It turns out to Pythagorean theorem. C squared is equal to a squared plus b squared. So this is what we call the amended version of Pythagorean theorem. So you take that c squared is equal to a squared plus b squared and put a correction factor. This is the correction factor which is not 90 degrees. Make sense? Go ahead and open the ACT 36 book, please. ACT 36 book. It's a white and blue Barron's ACT 36. Open page 154. 154. Well, you guessed it right. It's question number 15. Go. And that's your book. You can write in it and stuff like that, okay? So.
Matt.
Mm-hmm.
Yeah.
All right, let's get started here. Determine the expression that represents the angle R in the triangle PQR. So angle P is 110, sorry. This is 110 degrees. PQ is 7 and QR is 9. So they want this angle here. Of course, in the real ACT, I expect you to draw it so you can get a pictorial representation of a problem. Otherwise, you may make a lot of mistakes in this. Of course, they also have told in this problem is to use the law of sines. Nowadays, they don't. If they give it, you're lucky. I can tell you why the law of cosines cannot be used. I can tell you that because for law of cosines, if you're finding an angle, you need the 3 sides. It's not given, you can't do it, so you have to do the law of sines. Sine R divided by opposite sine is equal to sine 110 divided by opposite side 9. Cross multiply 7 sine R is equal to 7 sine 110 divided by 9. So now remember we talked about angle. You need angle, you need inverse. Sine inverse of 7 sine 110 divided by 9. And I believe this is how they gave the answer. Do you know why? Why would they keep the answer this way? Why didn't they go next step and get an answer? It's for people who don't have a calculator. Simple. And somebody tell me the answer after doing the math here, please.
46.959.
So let's go with 47 degrees. Make sense? Any questions, guys? $40, $43, $44, please. We can do some fun problems. $40, $43, $44. $40, $43, $44.
Forty, 43, and 44.
Mhm. Just after the 60th question, there is answers. Go and check your answers, please. 40, 43, 44. Okay. How many got all correct? One here. Excuse me.
Let's see.
Anybody online? All correct. One wrong.
Yeah, do you mind explaining number 44?
Yeah.
No, I get that.
I know.
I forgot what a chord
Yeah.
was.
When I said fun, I really wanted me to have fun. That's the reason, right? You can see, you guys are many of you are in 10th and 11th grade, and geometries are kind of in the past, so, yeah. Does anybody have a question on 40 and 43? Gotta be honest. Good.
Actually, for 43, I figured out a different way to do it. I guessed and I knew the answer just because of common sense, but I don't know how to do it like correctly.
Okay, let's do the correct way, okay? Because nowadays the answer choices are pretty tricky. So you can't, yeah. Find the height of a 17-foot ladder can reach on the side of a building when it hits the ground at 65 degrees. So this is question number 7. So we have a ladder at 65 degrees. It doesn't look like one. Okay, there you go. 65 degrees ladder. And how much it is? 17 feet? And it hits the ground at 65 degrees. Question is what? Find the height of a 17-foot ladder can reach on the side of the building. So they want to know if this is the building, at what is the contact time of this one. So this is the height. So it'll be sine 65 is opposite or hypotenuse. So h is equal to 17 sine 65.
Okay, yeah.
Make sense?
Yeah.
Should be whatever. What's the answer?
Be 15.4.
Okay. All right. 44. Very, very important question. Okay? Very important question. The diameter of a circle is 34 centimeters and a chord. So we have a chord. A chord is a line segment that goes from one point of the circumference to other point without crossing the center point. So this is a chord. So the longest chord is a diameter. Okay? So this is the chord. And how much it is? What is the distance? Okay. 30. Okay. And the diameter is 34, so the radius should be 17. They want you to find the distance from the center point to the chord. So listen up. A line drawn from the center point to a chord at 90 degrees bisects the chord, called perpendicular bisector. So that line segment becomes the perpendicular bisector to the chord. And this is so this becomes 15 and 15. And this one is, of course, is 17, which is your radius. Of course, this now is a Pythagorean theorem. Should be 8. 8, 15, 17 is a Pythagorean triplet. You guys can figure out the Pythagorean part of it, but I remember it is 8, 15, 17 as a triplet. This is why they gave the diameter, because this is the radius. They gave the chord so you could split it in half using the perpendicular bisector. This is one of the very famous chord properties you need to know. Chord is the most underrated thing in geometry. they're like, yeah, what's no? But I've seen many schools don't even learn about chords. ACT is pretty heavy on chords, especially if you want to get to that 34, 33 ACT scores in math. You can skip this. Any questions on this? You have a few minutes break time. You can log out of this, join Maddie's session in another 5 minutes or so, and keep doing the homework. Don't miss that. And if you want to be an expert in anything, you'll have to repeat anything 3 times. You cannot. Hearing is one. That's one step. Writing and rewriting and learning that's how you remember for a long time. Take care. I'll see you guys next week. Bye.